1.4 Complex Numbers Preparation. Okay, example, add and subtract vertically. All right, so we rewrite this. So we can rewrite 3a minus a b plus b. And then we would just add these together. So 4a plus 3a. 4 plus 3 is 7a. Then we say minus 2ab plus negative 1ab. So 2 minus 1 is 1ab. And negative b plus b, those just cancel out. Let's try over here. We're going to distribute the negative first, just to make it a little easier to deal with the sign. So you're going to flip all those signs, right? So I'm going to say negative 3x squared y plus xy plus 2y squared. And then we're going to rewrite all that, right? So negative 3x squared y plus xy plus 2y squared. We'll just add those together. Okay, so we say 2x squared y minus 3x squared y. So that'll give me a negative 1, or negative x squared y. Then we're going to say 3xy plus xy gives me 4xy. We're going to say y squared, and that's just to be a 1y squared, plus 2y squared gives me a 3y squared. Next, we're going to multiply polynomials. Now, unlike when you add and subtract polynomials, when you multiply polynomials, the exponents will change. Okay, and what we do is we add the exponents. Okay, so first I'm going to say, I'm going to rewrite this. I'm not going to do this every time, but I'm going to rewrite it with the constants next to each other. And then I'm going to rewrite it with the m squared multiplied by m to the first, right? So first we're going to multiply the coefficients. 8 times negative 9, which gives me a negative 72. Then we're going to multiply m squared times m to the first power. And when you multiply the same bottom, right, so the base has to be the same, you would add the exponents, and that would actually give me a cube. Okay, so since I have an m squared times m to the first, I get m cubed. Now that should theoretically make sense, right? Because m squared times m to the first power is really me saying m times m squared is that, right? So square means I have two m's, and I'm multiplying it by one more m, so I have a total of 1, 2, 3 m's. So shorthand for writing m times m times m is m to the third power. And that's how we get the product rule for exponents, right? And that should make intuitive sense, right? So again, I multiply 2 m's by 1 m, so I have a total of 3 m's being multiplied together. And the shorthand for writing 3 m's multiplied together is to put it to the third power. And that's it, right? Okay, so we end up with m to the third power. Okay, so let's try the next one. So again, we have 4 times 2. Okay, and I'll write, I'm not going to write after this one, but again, you could write 4 times 2, which gives me 8. Then you can write x to the third times x to the second. So you add 3 plus 2, and that gives you x to the fifth, right? You don't have to put dots here. I'm just putting it to illustrate something. And then finally, we have y to the second times y, which is understood or implied to have a 1 there, right? And since you have the same base, y squared times y to the first, you end up with a total of 3 y's. These are multiplication symbols, by the way, just to make sure that's clear. You don't actually have to put it. You would just put 8x to the fifth, y to the third, right? Now let's try a couple more. More product rule. So we're going to distribute within the parentheses here, right? So we are going to say 4 times 3 is 12, and x to the second times x to the first gives me x to the third. So you have 2 plus 1 is 3. Then you're going to say 4 times 5 is 20. And since you don't see an x over there, you're going to keep an x squared from the first term that you distributed, right? The 4x squared, you keep the x squared. Okay, so let's try another one. This is a little bit longer. It's okay. If you're distributing one term into parentheses, you just multiply everything within the parenthesis by the other term. It doesn't matter how many terms are within the parentheses, you just hit each of them once, right? So for instance, negative 8 times positive 4 is a negative 32. And m to the third times m to the third 3 plus 3 is m to the 6. 3 plus 3 is m to the 6, right? Okay, the next one you're saying negative 8 times positive 3, which gives me a negative 24. Then we're saying m to the third times m to the second. 3 plus 2 is 5. Then we say negative 8 times positive 2 would give me a negative 16. And now we say m to the third times m, which is understood or implied to have a 1 exponent there. So we would say 3 plus 1 is 4, so it gives you m to the fourth. Then you say negative 8 times negative 1, which gives me a positive 8. And you bring down m to the third. Okay, so now if you have a binomial multiplied by a trinomial or more terms, the key is you want to multiply everything within the first set of parentheses by everything within the second set of parentheses. Okay, so I'm going to start with the first one. So m squared times 4m cubed, right? There's understood or implied 1 there coefficient, right? So 1 times 4 is just going to be the 4. But anyways, so we're going to keep the 4, and m squared times m to the third, 2 plus 3 is 5. Then you're going to say m squared times negative 2m squared. Well, you're going to keep the negative 2, and then you're going to say 2 plus 2 is 4. Then you're going to say m squared times positive 4m, and that's an understood or implied 1 there. So you're going to keep the 4, and then you're going to say 2 plus 1 is 3. Okay, let's try a different color here. Try blue. All right, so now we're going to do the same thing we're going to do with the second one, right? Same kind of process though. So now we're saying 5 times 4 is 20, and m cubed, so we're going to keep the m cubed. Then we're going to say 5 times negative 2 is negative 10, and then we're going to keep the m squared on the second one. We say 5 times 4 is 20, and we're going to keep the m to the first power. Okay? And now what we have to do is we have to combine like terms, right? So we're just going to say 4m to the fifth seems to be the highest variable that we are, the highest degree that we have, highest exponent. So that one's simply going to be dropped down to 4m to the fifth. Next, we're looking for the next highest one, which would be a 4 right next to it. So it's negative 2m to the fourth. Next, it looks like we have a third degree, a positive 4m cubed. But we also have a positive 20m cubed. So 4 plus 20 is 24m cubed. Now, when you multiply, you do change the exponents, but when you add or subtract, you do not change the exponents. So we combine like terms, the coefficients, we add or subtract the coefficients, but we don't change the exponent. That's very important. I know that can be confusing, but the rules for addition and subtraction are different than the rules for multiplication and division. Okay, so next we have a negative 2m squared. It looks like the only one we have, so we're going to take down the negative 10m squared. And then it looks like we have a positive 20m to the first, so plus 20m to the first. You don't have to put a 1 there. It's just understood or implied. Okay, let's try the next one. Now this one's going to be done exactly the same way, but we are going to be distributing to more terms within the parentheses, right? So you're going to say 3x, this is understood to be a 1 there, right? 3x to the first power times x to the third power. So the 3 stays, but 1 plus 3 is 4. That 1 and 3. Okay, so next we move on to the next one. 3x to the first power times 2x squared, or 2x to the second power. So 3 times 2 is 6, and x to the first times x to the second. 1 plus 2 is 3. Then we move on to the next one. So we say 3 times 4 is 12. We say x to the first times x to the first. There's an understood 1 there. We're going to say 1 plus 1 is 2. Then we say 3 times 1 is 3. And we also have the x. So basically 3x times 1 is just 3x. So next, we distribute the second one, right? So we're going to say, now we're going to deal with this one. So 5 times x cubed, 5 times 2x squared, 5 times 4x, and 5 times 1. Okay, so we say 5 times x cubed is going to be plus 5x cubed. Then we're going to say 5 times 2x squared, which will give me 5 times 2 is 10. Keep the x squared. Then we're going to say 5 times 4x. The first power is going to be 5 times 4, which is 20. And we just keep x to the first power. You can write a 1 there if you want. And then you say 5 times 1 is 5. Okay, now we need to combine like terms, right? So now we're going to combine like terms. So we go descending order. I see 4 here. I don't see anything larger than 4, so I'm just simply going to bring down the 3x to the fourth. Next, I see a cube here, a positive 6x cubed, and I say positive 5x cubed here. So 6 plus 5 is 11. So we end up with 11x cubed. Then we go over to the next one. So we see a 12x squared and a 10x squared. They're both positive. So you're going to say 12 plus 10 is 22. And then we just keep the x squared. Next, we have a positive 3x and a positive 20x. Those are like terms. So 3 plus 20 is 23x. And then we have a constant over there of plus 5. And that's it. All right, so we're going to say product of sum and differences of two terms. Okay, the product of a sum and difference of two terms is a binomial consisting of the square of the first term minus the square of the second term for x and y. The following holds true. X plus y multiplied by x minus y is equal to x squared minus y squared. This seems complicated, but once you memorize this pattern and understand it, this is actually not bad. So first I'm going to do it without the pattern, and I'll show you why the pattern works, right? So for instance, we would say x times x to the first power times x to the first power. And we would say that 1 plus 1 is 2, so we end up with an x squared, right? Then we would say x times negative 4 is negative 4x. We would say x times positive 4 times x is positive 4x. And then we would say positive 4 times negative 4, which would give you a negative 16. Now, notice that negative 4x and 4x cancel each other out. And since they cancel each other out, we're left with x squared minus 16. And that's what this pattern right here is trying to tell you. That if you multiply the same binomial, but they're conjugates, they have one is addition, one is subtraction, then what you're going to have is the first term squared. And then what happens is the two middle terms are going to cancel out because they have opposite signs. And then what's going to happen is you're going to end up with the last term squared, minus the last term squared. So this pattern right here is always going to happen. So I'll do one more where I do it the long way. 8 times 8 is 64. 8 times x is positive 8x. Negative x times positive 8 is negative 8x. And then finally, negative x times positive x is negative x squared. Notice again that the two middle terms cancel out, leaving me with 64, which is 8 squared, minus x squared, which is obviously just x squared. Okay, so let's see if we can do it with a pattern without doing it the long way. So what we're going to end up with here is 5m squared minus 3 squared. If everything works out, that's what we should get. So now, this is a little bit different in that you actually need to multiply both the 5 and the m by themselves, right? So you're saying 5 squared. I'll even write this up because I haven't really covered it yet. But okay, so that's the one of the power rules of exponents. Okay, which basically says if I have more than one term within the parenthesis and it's all brought to a power, I need to bring all the factors, if there's a single term inside, bring all the factors to that power. So I'm saying 5 squared and m squared. 5 squared gives you a 25, m squared just stays m squared. In this case, it's a little easier, and this is just going to be, 3 squared, which is just minus 9. Okay, now we're on the last one. Now this one's a little bit different in that, so we have a 4x here and a 4x here, they match, but notice that the second term don't match. Okay, so you can only use this pattern when you have the same two terms, but one's addition and one's subtraction, or they're conjugates, put it another way, conjugates of each other, right? A binomials with opposite signs in the middle, right? Now this one does not fit that pattern, so if we were going to do this one, we have to do it the old way. So for instance, we say 4 times 4 is 16, x times x is x squared, right? And then we say 4 times negative is negative 4, and then we're going to say x times y is xy. The next one, we're going to do this one. 3 times 4 is 12. And we're going to say 12x. And then we say 3 times negative y is negative 3y. Now notice that none of these have like terms. We have an x squared, we have an x and a y to the first power, we have an x to the first power, and we have a y to the first power. None of those are like terms because they don't have exactly the same variable or variables to exactly the same power. And as such, they are not like terms, and you cannot combine it. Since you can't combine them, this whole entire thing right here, as ugly as that seems, is your answer.